Welcome to the Pre-Med Preacher. Today we're doing an exam review for Physics 250, so we'll get right into it. Hope you guys enjoy.
Familiar. So if you don't know by now, then you should probably get familiar.
Pause the video and read question 11. This question you have to break down into the x direction and the y direction. For force 2, you can clearly see it. There's no force in the positive or negative y direction, and there's only a positive 6 Newton force in the positive x direction. However, for force 1, we're going to need to use some trig. In the y direction, 15 sine 30 will be equal to negative 7.5, which is how much force is being exerted in the negative y direction by force 1. If we calculate the x direction using trig, 15 cosine 30 is equal to negative 13. Now, what we have to do here is sum up the x direction forces and the y direction forces. So in the y direction, force 1 is contributing negative 7.5 newtons, and force 2 is contributing 0, for a net of negative 7.5. In the x direction, force 1 is contributing negative 13 newtons, while force 2 is contributing positive 6 newtons, for a net of negative 7, which corresponds to answer choice C. Take a moment to read question 12. This question is tricky. Because he's in intergalactic space and the rocket ship is in an environment that is devoid of all air and gases, there is no equal and opposite reaction when the thrusters would engage. Therefore, if the spaceship is already cruising through intergalactic space, in order to keep it cruising in a straight line and at constant velocity, you will not have to turn the engines on because there is no net force acting on the spaceship already. Pause the video and read question 13. For inclined surfaces, we know that the normal force is perpendicular to the inclined surface, so we can automatically eliminate answer choice A. We also know that the force of his push is going to be up the ramp because that's where he's trying to move the box. So we can eliminate C and D because the force of push is in the wrong direction. Now the question is friction acting with the push or against the push? When moving the box up a ramp, you're going against gravity. Therefore, friction is going to act in the opposite direction and is going to oppose the force of the push, which corresponds with answer choice E. Take a moment and read question 14. This ball is rolling in the x direction off a table. Once the ball leaves the table, it's in free fall. One of the key aspects that you should know about free fall is that while there is acceleration in the y direction, there is no acceleration in the x direction. The velocity of the ball will also remain constant in the x direction, but there will be an acceleration in the y direction, which will increase the velocity in the y direction. For this specific problem, only the acceleration of x is equal to 0 just before the ball hits the ground. For question 15, we have another great example of a kinematics problem. They give us v initial in the x direction is equal to positive 6 meters per second. V initial in the y direction is equal to 0 meters per second. The time it takes is 0.5 seconds, and we know the acceleration, since we're on Earth, is negative 9.8 meters per second squared. Now, we can use one of the kinematic equations, delta x equals v initial in the x direction times time plus 1/2 acceleration times time squared. When we plug into this equation, we find that delta x is equal to positive 3 meters. And this is because the acceleration in the x direction is equal to 0, once the ball is in free fall off the table.
Familiar, you're familiar.